Success is not final. Failure is not fatal. It is the courage. It is the courage to continue that counts. I, Abhinav Negi, welcome you all on BYJU'S exam prep. And yes, guys, the 50 mark series is going to start with this session. This is the first session for civil and mechanical both, as we are dealing with the common subject strength of materials first. And guys, 50 marks will be covered in the next 2 months. It will be going to a long journey. And if you follow these lessons, I'm assuring you that you can get at least 50% of the marks. And guys, there is ample amount of time later on also. And then you can capitalize and go beyond 50 marks. Guys, now question may arise to some of the students. Sir, you just have told that this series is for 2 months and you are saying 50 marks? Yes, I am saying that. Then sir, in that proportion, in next 4 months, the syllabus will be going to complete. Guys, initially when you are going for the marks, with less study, because for only the important topics and the topics that are coming in more frequently, you are getting more marks. But going from 50 to 70, 70 to 80, 80 to 90 is not that easy. So first of all, we are going for the 50 mark series, and then later on with some other topics we will be going further, guys. Okay, so I, Abhinav Negi, welcome you all, guys. Can you please write down in the comment box or put a heart sign on the comment box and tell me how is the Josh commandos? Okay, and I will be telling you this session from zero level. It is not like that I am assuming that my students are knowing this and this and this and then I am going forward. No. I am assuming that you will be going from zero level. I will be telling you the concepts. Okay, then directly I will be going to the problems, guys, and that problems will be gate level. 1 marks and 2 marks both, MCQ, MSQ both will be there, guys. Okay, I am not sure, might be NAT is also there, otherwise NAT will be coming tomorrow. MSQ will be 100% here along with MCQ. Hello Rahul, Kalyan, Pejal Word, Arun, Sukrit Banerjee, MJM. Guys, please share the session so that more and more commandos can join in. This is about me. My name is Abhinav Negi. I have 11 plus years of teaching experience, done my M10 from IIT Delhi, got All India rank 164, but this is of no use, na? If I am teaching you, you're getting that is much more important than all these things. Now, sir, how 50 marks will be going to cover, sir? Now, let me tell you, we all faculties of civil and mechanical have prepared it, the 50 marks. Like I will be taking in this series, SOM, soil and survey. A few sessions of SOM, soil, survey. Soil comes of 16 marks, guys, 16 marks, but I have only counted 4 marks here. That whatever the topics I have taken, on an average from those topics, from last 5 years, 4 marks questions are there. Similarly, surveying 2. Okay, similarly, I have done 11 marks here. Okay, then transportation plus FM, this is all going to come for an aptitude on maths is of 28 marks, 28, but we have only counted 13. So by taking a huge factor of safety, this 50 marks is coming, guys. Okay, these are the subjects. Now for mechanical students, like Dheeraj sir has 14 marks, then Surat sir 12 marks, and the Shekhar 11 marks, and the Shekhar sir 11 marks, maths aptitude 13, and then it is going to 50 marks. Okay, so complete planning has been done. We are not coming here directly, muh utha ke aage bhai, no. Okay, so guys, ready? Everyone, this I will provide in my Telegram group also, guys, Civil by Abhinav sir. Please share the session so that more and more sessions students can join, guys. Happy Guru Purnima to all of you also. In some of you guys, in most of the times, many things a teacher learn from the students also. Okay, so many students here are record breaking today. Excellent. Okay, let's move further, guys. So first of all, let me tell you about little bit about elastic constants and thermal stress. There might be some of the things I will be telling you from the questions. So beautiful questions will be there. And one more important thing. We have done the hard work for this, guys. And you can observe this, that apart from two questions, every question that I'll be taking in this series, or in this session is new question that I have never ever taken in YouTube. 2 questions will be repeated because I believe that those 2 questions are very important to understand this topic. But apart from that 2 questions, the MSQ or whatever other questions are there that I have put today in this session will be new, that I have never ever taken in YouTube or have free class. Okay, let's begin. Guru okay, पूरा जोश है भाई, पूरा जोश है आज. कभी आधे रास्ते चलकर वापस मत आना, क्योंकि वापस उतना ही आना पड़ेगा जितना आगे जाकर मंजिल मिल जाती. Okay, let's begin. So guys, first of all, let me tell you about elastic constants, and after that I will be going to the thermal stresses. Okay, let's begin. Let's begin with the first elastic constant, that is Young's modulus, or also called as modulus of elasticity. Now, I can tell you that Young's modulus is normal stress by normal strain, and I can go forward. Young's modulus is normal stress by normal strain. Normal stress is force by area. Normal strain is delta by L. Let's go further. Next slide. No, let me go a little bit deep here. You are coming here in Abhinav Negi's session not only to know this. Okay, I'll tell you much beyond than this, guys. See, Young's modulus is the ratio of normal stress by normal strain, but only in 2 conditions. This you might not be knowing. Only in 2 conditions. Okay, otherwise most of you are till now only studying Young's modulus is stress by strain, Young's modulus is stress by strain, Young's modulus is stress by strain. No, no, no. It is stress by strain, not always stress by strain. It is only in 2 conditions. First condition, that it is within the proportional limit. Hooke's law is valid. Okay, it is in proportional limit. Let me explain you a bit. It should be within the proportional limit. Let me tell you. Guys, suppose I am drawing the stress strain curve for mild steel. I am drawing the stress strain curve for mild steel. Going deeper, guys. Very deep I'll go. Otherwise, Young's modulus is stress by strain. Next slide. Shear modulus, shear stress by strain. Shear strain. Next slide. No, no, no. Okay. So guys, it is linear here. Then something like this, some plastic region, strain hardening region, and fracture here. So at this point, stress by strain is not Young's modulus. At this point, stress by strain is not Young's modulus. Only before proportional limit, at this point, stress by strain is equal to Young's modulus. Now listen to me. If I am saying y-axis as stress and x-axis as strain, equation of a straight line is y is equal to mx plus c, but if that is passing from origin, the equation reduces to y is equal to mx of a straight line. Y by x is equal to m, that is slope. Y is here stress, x here is strain, is equal to slope. Slope means this theta, tan theta, and this tan theta is Young's modulus. So stress by strain is Young's modulus. इसका जो origin है, the starting of the derivation or whatever you call it, the expressions is coming from the equation of straight line. So stress by strain is equal to Young's modulus is only valid up to the proportional limit. Not here, stress by strain Young's modulus, not here, not here, not here. And it is our general assumption in SOM that Hooke's law is valid. Okay, otherwise the stress that is coming to your member, in your machine, in your building, if you do stress by strain is not equal to Young's modulus, because generally Hooke's law is not valid, because stress strain curve is linear, is not possible for all the materials. Okay, enjoying the session, guys? Give me yes or no in the comment box, guys. Have you learned this first time or not? If you have learned, guys, I am not that kind of teacher that I will be happy that you are learning this first time. If some of you already knowing this earlier, I will be more than happy that intelligent students are coming in my session. Now, going further, everybody, ready, guys? Ready, just let me know. Now second condition. The second condition is it is only valid for unidirectional loading. It is only valid. Soon I am coming to the question also. Unidirectional loading. If the load is If the load is in two direction, then stress by strain is not equal to Young's modulus. If the load is in two direction, then stress by strain is not equal to Young's modulus. Okay, if suppose the member is like this, and in this member, suppose so it is going here, it is going here, it is going here, it is going here. Suppose this is x direction, then stress in x direction upon strain in x direction is not equal to Young's modulus. This is only valid for unidirectional loading. It is only valid for uniaxial loading. Give me yes or no, everybody. Give me yes or no on the comment box. Everybody on the comment box. Come on, yes, yes, yes. Many comments I am getting. Yes, my friends. Yes, 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 yes. Okay, 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 okay. Let me go further. Okay. So this is about Young's modulus. Stress by strain is equal to Young's modulus, and it is only valid. It is only valid when it is in proportional limit and it is unidirectional loading. Okay, now let me go to the second Young's modulus, a second elastic constant, that is shear modulus. It is represented by G or C. It is represented by G or C. It is called modulus of rigidity, or it is called as shear modulus. Now guys, see, everyone guys, suppose this is a lamina and here shear stress is acting. If this is tau, then all taus are equal. If this is tau, then all taus are equal. Can you note the one from my typing team, one mistake is there? Can anybody tell me here on the comment box? From my typing team, one mistake is there. Can anybody tell me? Can anybody tell me? Yes, 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 yes. This is for civil and mechanical both. This is for civil and mechanical both. फोड़ देंगे भाई. Guys, there is one mistake. Can anybody tell me? Tell me. Yes, direction. Good. Guys, this here will be in this direction because either arrow to arrow will be leading or tail to tail will be there. Arrow to arrow will be there or tail to tail. Tail to tail, arrow to arrow. I can prove this. I can prove this. Wait. Let me prove this. Suppose this is a lamina. This is a point. I can prove this. The derivation that I usually do with long derivation, that I can do with words only. See, if this is shear in this direction, then 100%, because in SOM we are dealing with equilibrium body. 100% the next shear will be here, so that summation of force in x direction should be 0. If this tau is upward, then 100% here it should be downward, so that it should be in moment equilibrium. It should be in force equilibrium. If this is upward, this should be downward. And considering the movement about this point, if this tau is rotating about this point clockwise, then this tau is rotating it anti-clockwise, so that it is in moment equilibrium also. So both taus are equal. Give me yes or no. Okay, so either tail to tail or arrow to arrow. So DTP की गलती से okay, let me fix the camera. My son has done this. Sorry for the disturbance. Now it's fine. Now, friends, from the mistake of DTP, you got to know one thing more. Okay. Now, see here, everyone. Shear modulus is, or G, is shear stress by shear strain. Now, what is shear strain? So, first thing, sir, is this also valid for uniaxial loading? No, because one tau cannot never come alone. एक tau कभी आ ही नहीं सकता. If there is one tau, then all other taus should also be coming. So, one tau will never come. If there is tau, then other three are definitely coming. Okay. Now, see, in SOM, we are dealing with deformable physics. Here, the length of the body can elongate, can compress, shape can be changed. We are not studying the rigid body physics here. We are studying the deformable physics here. So here, due to this kind of shear, the deformation is like this. And earlier the angle was 90 between these two planes. Now the angle is little bit reduced. 90 minus gamma, it can be reduced, or at some place it can be increased also. So whatever is the change in angle, earlier is the 90, now it is 90 minus gamma. So that change in angle is shear strain. So shear stress by shear strain is shear modulus. We are soon coming with the questions also. Now bulk modulus. Bulk modulus is hydrostatic stress upon volumetric strain. Okay. So this is delta V by V. Volumetric strain is delta V by V. Why this is hydrostatic stress? Because water's pressure at h height is rho gh and it is same in all direction. Water pressure at h height is rho gh and it is same in direction. There it is also sigma, 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 all are equal. It should not be sigma 2, sigma 3, sigma. All are equal and in the same direction, either all three compressive or all three tensile. When it is equal in magnitude and it is alike, same direction, either all three compression or all three tensile, then with that stress, what is the change in the volume? That is bulk modulus. Because in water also, if this is a vessel, if this is a vessel, in this vessel, at h height below, the pressure is rho gh, and that is equal in all direction, equal and alike in all direction. For that stress, bulk modulus is defined. Now your question can be, sir, if this is a body, and only this sigma and this sigma is there, is bulk modulus defined? No, it is not defined in that case. Only when you are applying sigma, sigma, sigma in all three direction, then whatever is the volume change, sigma by volumetric strain, that is the bulk modulus. Can you all tell me on the comment box one thing? That what is the bulk modulus of rigid body? Tell me on the comment box. And after that, tell me what is the bulk modulus of incompressible fluid? What is the bulk modulus of incompressible fluid? Everybody on the comment box. Everybody on the comment box. Fast, fast, fast. Fast. Everybody. Okay. So many students are here. Excellent. Okay, strain, it is what is the answer? Infinite. Surjit, no Lakshmi, Arnab infinite, Arun Kumar infinite. Okay, grammar infinite. Because for them, rigid means no volume change, no shape change, no dimension change, no length change, no width change, no height change. Rigid means वो टस का मस नहीं होगा भाई. It will not be changing anything. So denominator will be 0. Incompressible fluid, delta V0, that is denominator 0. So it is infinite. That means what is the physical meaning of bulk modulus? What is the physical meaning of bulk modulus? The physical meaning is somebody is asking you in an interview, then you have to say how much big is the bulk modulus, how much big is the bulk modulus, that much more incompressible that body is. If anybody has a greater K, that means it is not pitching. It is not pitching in the pitching in English means it is volume is not changing. Okay, more K, more it is towards the rigidity. Okay. Now, there is one more Poisson ratio that we'll deal in detail in some other case. It is minus of lateral strain upon longitudinal strain, not latest. It is minus of lateral strain upon the longitudinal strain. Okay. Why minus? First of all, what is longitudinal? The direction of force or the direction of stress is that direction is longitudinal. Longitudinal is not the bigger here. The direction. Okay, the direction of stress is the longitudinal and opposite is lateral. So here what is happening? Mu is equal to minus of lateral by longitudinal. So what is lateral? Lateral is this direction. So here it is decreasing. Decreasing means compression means minus. This is longitudinal. Increasing means plus. So one more minus minus, it is plus. Now let me tell you another body. Another thing. Mu is equal to minus of lateral strain upon longitudinal strain. Suppose the body is this and I am pitching it like this, applying compressive force like this, pitching compression here like this. Now with application of this kind of force, it is going like this. So here mu is equal to, for this body, lateral is longitudinal is the direction of force or stress. Opposite is, for this stress, this is longitudinal and this is lateral. For this kind of stress or force, this is longitudinal. The direction of stress is longitudinal and perpendicular to that is lateral. So here minus ye wala minus hai. Lateral is this one, that is plus, and longitudinal is this one. Here it is compression minus. So it is again coming plus. But it is not like that mu is always plus. For human tissues and polymer, mu can be negative also. And mu will always be less than 0.5. The maximum value is 0.5 and it is 0 for cork and it is 0.5 for rubber and plastic material. That whole 0.5 ki kahani hai, that volume is 0 in. For mu 0.5 volume change is 0. That is some story, Poisson ratio, you can see my video, I am not going detail in there. Okay. Now sir, why mu is minus? Because sir, you just told if one is increasing, other is decreasing. So mu minus means, suppose that material will be like this. If I elongating it, so in both direction it is increased. So mu is equal to minus of lateral strain. So it is increasing here also, both are plus. Then only it will be minus. Na? Yes, this is the case for human tissue and so polymer. Because if you see from this microscope, the human tissues and polymer, if you suppose this is the point and you see from the microscope, okay, then if you see that point, there are structures like this, there are hinges, there are structures like this, two in, and if you are pulling it like this, then in both direction it is increasing. The structure, the complex structure is like this. That in both direction it is increasing. So lateral is also increasing. Longitudinal is also increasing. So only due to this minus sign it remains minus. Give me yes or no on the comment box. Everybody. Please let me know, guys. Everyone. Let me know. Enjoying or not? Soon we are going to very new questions, guys. You will be enjoying like anything there. Guys. Okay. Okay. Chalo. This is the first session, guys. 50 marks will be covering here. Now, homogeneous and isotropic, let me tell you, homogeneous, isotropic, let me distinguish both of them. What is homogeneous? Suppose this is a body, and if I am saying this body is homogeneous, then that means at one point, this is the one point, in x direction if the property is alpha, isko mat dekho, this I will give in PDF here, see me. Then this is the second point, in x direction the property should be same, alpha. In third, in x direction the property should be same, alpha. So in same direction, in x direction property of all points 1, 2, 3 is same. In y direction the property may be different, beta. In y direction the property may be different, beta, but here also y direction it should be beta property. That property can be anything. That what is the thermal coefficient here, what is the thermal coefficient in this direction, it can be anything, guys. Okay, at one point in x direction and y direction may be different, but all points x direction should be alpha, y constant beta. Now what is isotropic? I can go to the different slide for isotropic, but I want to explain here only. In isotropic means, if this is the one point, in one point is x direction is alpha, in y direction should be alpha, in any direction it should be alpha. So at a one point in all direction x, y, z it should be same. That is isotropic meaning. In two point, if this is beta, then in 2 point in all direction it should be beta. This is isotropic. So that is the difference between homogeneous and isotropic. Homogeneous gives preference to the direction, that in same direction property should be same. In y direction the property should be same. In x and y may be different. Isotropic says no, here the direction is not important, point is important. At one point in all direction property is same, at 2 point in all direction property is same. But our assumption in SOM is what? The material is homogeneous and isotropic both. our assumption in SOM is the Hooke's law is valid, and our assumption is homogeneous and isotropic both. So homogeneous and isotropic, that means it should be alpha, alpha, alpha here, and this is the 2 point. Since it is isotropic, so all points are alpha, all directions are alpha at 1 point. Since it is homogeneous, so at 2 point in x direction should be same, alpha. And since it is isotropic, so now all should be alpha. Give me yes or no in the comment box if you got it. Give me yes or no in the comment box if you got it, guys. Everybody on the comment section. Everybody on the comment section. Enjoying or not, guys? Getting the things? Soon we are coming to the very good questions, guys. Soon we are coming to the very, very good questions. If you have any doubt, please explain. Please let me know there. Only Arun is telling, what about others, guys? Okay. Now, see, we have studied 4 elastic constants. Okay. E, stress by strain, is equal to Young's modulus only in the case of proportional limit and unidirectional loading. Shear modulus by shear strain is shear modulus, sigma by volumetric strain. What is the significance of K? That you have understood. More is the value of K, more incompressible it is. Poisson ratio you have studied. Now the relation between E, G, mu, K is this. I am not going into derivation. Okay, this you can take screenshot, otherwise I will give you in PDF. The relation between E, G, mu, K. Okay, E is normal stress by normal strain. G is shear modulus, shear stress by shear strain. Mu is minus lateral by longitudinal strain. And K is sigma by volumetric strain. The relation between them is like this. Okay. Now, guys, how many total elastic constants if somebody asks? This is asked many times in the previous year questions of civil and mechanical. Okay. What is the total number of elastic constants? भाई उसकी क्लास चल रही है क्या ये कि DTU का स्ट्रक्चर कैसा है? DTU का स्ट्रक्चर बहुत अच्छा है. गुप्ता इंजीनियरिंग कॉलेज के रॉक मैकेनिक्स से बहुत अच्छा है, लेकिन IIT दिल्ली के रॉक मैकेनिक्स से भी बेकार है. तो अच्छा है बुरा है रिलेटिव टर्म्स में काम होगा ना. आपकी रैंक 300 है तो बहुत बेकार है, आपकी रैंक 10,000 है तो बहुत अच्छा है. Yes, it is not coming one time, many times. Total elastic constants are 4. Total are 4, but independent are 2. Because if you know any two, suppose you know K and G, so mu can be obtained. Suppose you know K and G, so E can be obtained. And not only K and G, any two. Suppose K and mu are known, so E will be known. Now once E is known, mu is already known, so G is also known. So from any two you can find remaining 2. So independent are 2, here it is 9 and it is 21. Okay, so that we will do in different day. What is or different session I will take on that. Okay, now going to the second part, then after that I am coming to the questions, guys. Whenever there is temperature, body wants to elongate, and if it is free to elongate, nobody is resisting, stress will be 0. Stress will be obviously 0. Okay, but if there is some restriction, if it is free, stress will be 0. Stress will be 0 here. Okay, but if it is fixed here, length is L, coefficient of thermal expansion alpha, temperature delta T increasing. Okay, Young's modulus E. Now if temperature is increased, it wants to increase L alpha delta T. It wants to increase L alpha delta T, but it is fixed, it will not be able to increase. So some internal forces will be coming. This P will push it back here. Of course it will increase both sides. I am just showing only one side for better understanding. So this P is coming and PL by AE. This P is coming such that there should not be any elongation. This is pushing it back here. L alpha delta T. So L to L is cancelled. P by A is stress. Okay. Stress is equal to E alpha delta T. If temperature is increased, it wants to increase, but it is fixed. It cannot increase, so compression will be coming. If temperature is decreased, so it wants to shrink, but fixed support is not allowing it to shrink, then same stress will be tensile. I am again saying, if temperature is increased, it wants to increase, stresses will be compressive because fixed support will not allow it to increase. Similarly, if temperature is decreased, so it wants to decrease, but fixed support will not allow. So खींच के रखेगा उसको tensile stress. And sometimes थोड़ा सा घुमाएगा क्वेश्चन, वो क्या करेगा? वो कहेगा टुई टू कहेगा एक हल्का सा गैप है यहाँ पे डेल्टा का, या मूव कर सकता है, या ये एक तरह राइट साइड ऑफ द सपोर्ट इज लिटिल बिट मूवेबल. In that case, same thing you have to do. If temperature is increased, so this P is coming, but P is not pushing it back here. If this length is delta, this is L alpha delta T minus delta. Because this P is pushing from here, this P is pushing from here to here. PL by A is pushing this much. But here the PL by A is pushing from here to here. Here the PL by A is pushing from here to here. This is L alpha delta T, this is delta. So is it pushing this much only? Give me yes or no in the comment box. Give me yes or no in the comment box, guys. Everyone. Keep sharing, keep sharing. Yes, Rotelaji, good evening, everyone. Okay. Now let us go with some questions. This is just a beginner. This is not the question of elastic constant, but still if you want to give me the answer. Okay. A solid metallic bar tapers from 40 meter dia to 20 meter dia. This is the question of deformation, but it's okay. This is just a starter question. Main course is coming after this. Main course is coming after this. So here the load is 20 kilonewton. Main course is coming after this question. 20 kilonewton. And the diameter here is 40 mm. Diameter here is 40 mm. And here the diameter is 25 mm. Okay. So length is 500 mm. Young's modulus is given. So what is the elongation? Can anybody let me know? Can anybody let me know in the comment box, guys? Can anybody let me know? The elongation of a tapered bar is given by 4PL pi D1 into D2 into E. Every term is given. Young's modulus is given, P load is given, D1 is given, D2 is given, length is given. Now once you apply this, might be you're getting, please check, it will be getting 1 upon 5 pi. 1 upon 5 pi. Give me yes or no. Give me yes or no in the comment section. Have you understood? Now I'm going to the main course, guys. Now I'm going to the main course. भाई कुछ yes no तो बोल दिया करो, कुछ yes no तो बोल दिया करो, कुछ yes no तो बोल दिया करो भाई, कुछ yes no तो बोल दो, कुछ तो एनर्जी दिखाओ भाई. चलो, main course started. Main course started now. Beautiful question. Here the students find some difficulty. A steel rail is 15 meter long and is laid at a temperature of 20 degrees Celsius. The maximum temperature in summer, it is laid at 20 degrees Celsius, but temperature can increase up to 45 degrees Celsius. The minimum gap, if you have seen in railway tracks, there is a very thin gap. The minimum gap required so that no stress, koi stress na aaye. Guys, if even after summers, the elongation of the rails, even after summers, the elongation of the rails is such that it is not touching the another one. If this is first one, after summers, it is not touching the second one. There is thin gap na. Here is the gap na. It is not touching the second. Then no stress is coming. If anybody wants to increase and it is increasing, there is no touching from something, there is no constraint, no constraint, then there will be no stress. Got it? Got it? Got it, guys? Okay. That means this is a rail of 15 centimeter or 15 meter long. Then this is again a rail 15 meter. Then this is again a rail 15 meter. Now what students do mistake here, that they think, suppose this is the, we are considering this one. So they think, so this will increase both sides. So they think that Let us consider only right hand side. So they think that this is length L by 2. L by 2 alpha delta t should be the gap because it is only increasing here. So this is wrong. If you are doing this, this expression is totally wrong. Why? What mistake you have done here? If you are thinking, sir, yaar, this is not that easy question because it is increasing both sides. So we'll be taking only L by 2 because remaining L by 2 will be increasing here. This L by 2 is increasing here. Okay, you are thinking like that. But in that case, you cannot make it equal to gap, na? You cannot make this L by 2 alpha delta t equal to gap. No. Because this will also increase to here, na? Only you are thinking that this will increase here. No, this will also increase to left hand side, na? Not only this will increase to right, this will also increase to left side, na? As this is increasing to right, this is also increasing to left, na? So instead of that, if you want to see it only in that way, L by 2 alpha delta t, this is L by 2, then this should not increase up to gap. This should increase only gap by 2. Okay, this should increase only gap by 2 because remaining gap by 2, this will also increase here, na? This blue one is increasing only, can increase only up to gap by 2. Okay, then this green one should be increasing gap by 2. If this is happening and it is not increasing beyond that, that means there is no touching. No touching means no stress. So instead of this relation, you have to write this. Give me yes or no in the comment box if you got it. Give me yes or no in the comment box if you got it. Give me yes or no in the comment box if you got this. Please, my friends, on the comment box. Otherwise, I'll not go further. Okay, so if you put this value, how much is the answer coming? This is coming 4.5 mm. This is coming 4.5 mm. Keep sharing and like the session, guys. Come on, yeah. Like the session. Everyone. Okay, next now question number 3 is MSQ. Question number 3 is MSQ. These guys have never ever come with the workbook questions on YouTube. The workbook that we are providing to the free paid users. This is the first time that I am coming with the workbook sessions, and this is the first and the only time. I am coming with the workbook questions. Couple of questions are workbook here, just to show the quality of our workbook. Practice करना पड़ेगा सुजीत. So guys, see, strength is the property of material which does not depend on shape. Concrete की strength है. If you take a cuboid beam of 200 meter or 10 meters or 12 meters, whatever you take, you never said that the strength of this is this for this shape. Okay, it is independent of this, independent of size, independent of load. Load के कारण stress आएगा, strength नहीं. Due to load, the stress will be coming. Strength nahi. I have some workload. It will cause stress on me. My strength will not be decided on the basis of load. Okay. So material, about materials, material, molecule, homogeneity or not homogeneity, this will decide the strength. Okay, so A, B, D are the things that are not deciding. Now see, this is the question of our workbook. This is the level of our workbook. This is the question of our workbook. Okay, so the length is varying as L is equal to L naught T plus T square. Length is varying with temperature. Calculate the deflection. After this question, I will tell you an interesting thing. Okay. L is equal to L naught T plus T square. Now, calculate the deflection due to temperature change of T. Guys, if I take a small length, What is the deflection? L alpha delta T. What is the deflection? L alpha delta T. So L alpha delta small temperature is dt. So from here dl, what is the value of L? It is L naught T plus T square alpha into dt. What is the total change? What is the total dl? What is the total delta? Changing from 0 to T. Temperature change is T na? 0 to T. So from here L naught is constant, alpha is constant. Now 0 to T, I am integrating T plus T square dt. So this is L naught alpha T integration or dt will be T square by 2. So putting the limits, it will be T square by 2. Now this will be T cube by 3. Putting the limits, it will be T cube by 3. So please check what is the answer coming. Please check. It is from here, if I take T square common and 6 common, from here L naught alpha T square common I am taking and 6 common. So what is remaining here? 3 plus T square common and 6. So here it is 2T. Please check, please check, please check, please check. T square into T is T cube by 3. So L naught alpha T square by 6. 3 plus 2T, that is A option. This is the level of our book, guys. Give me yes or no for this beautiful question. Give me yes or no for this beautiful question. And guys, keep liking and sharing the session so that more and more sessions, more and more students can join in. Everybody, please share it. Are you enjoying the session, guys? Tomorrow also I am coming at 9 p.m. 50 mark series. Tomorrow also I am coming at 9 p.m. with the universal method of slope and deflection by AN method. Abhinav Negi method. I'll tell you a deflection method from which you can do all the questions. Area moment has some limitations. Double integration has some limitation. McCulloch's has some limitations. Strain energy has no limitation. It can be used everywhere provided temperature is constant. Whether for frames, whether for cantilever, whether it is zero slope or not slope, whether it is internal hinge or not hinge, whether it is prismatic or non-prismatic, everywhere strain energy can be used. And for that strain energy, for that universal method, I'll be telling you a shortcut tomorrow at 9 p.m. Okay. Now, before going to this question, now PDF I'll give you, don't worry. PDF I'll give you in civil by Abhinav sir. Let me ask you, some of the students who are regularly following me from last months, they might be knowing this. They might be knowing this. But for other students, let me ask. I am dividing your mobile into 4 parts or dividing your laptop in 4 parts. Okay. I just want a clear answer from all of you that how many examples you know. Case 1, case 2, case 3, case 4. Your screen I have divided into 4 parts. Crack aa gaya usme. Okay. Now, one case is stress is not equal to 0. Strain is not equal to 0. Do you know the example of this? Stress is equal to 0. Strain is not equal to 0. Do you know the example of this? Stress is not equal to 0. Strain is equal to 0. And stress is equal to 0. Strain is equal to 0. I just want one answer from all of you. That out of these 4 cases, how many cases you know? How many examples you know? Out of these 4 cases, how many answers you know? How many examples you know, guys? Everyone. Everyone on the comment section. Out of these 4 cases, you know 1, you know 2, you know 3, you know 4. How many? How many? How many? How many? Please, please, please let me know. Tomorrow again I am coming 9 p.m. Tomorrow again I am coming 9 p.m. Tomorrow again I am coming 9 p.m. for the universal method of slope and deflection. Come on. Come on, come on. Vishal, it is good for preparation. It is good for preparation. Like see, this for this case answer is this. Here stress is also coming, P by A, strain will also come. Stress is 0, strain is not 0. So this case there is a bar and temperature is increased. So stress will be 0 because the free expansion is allowed. The free expansion is allowed, so stress will not be there, but strain is not 0. Where L strain will be delta by L. So delta is L alpha delta T by L. So alpha delta T. Stress is not equal to 0, but strain is equal to 0. This is the case. Temperature is increased. So strain is 0 as it is fixed, but stress will come due to temperature. Stress not 0, strain not 0. Put a bar here. Delta is 0. No temperature change. No force. No force, no temperature change. So neither the stress will be coming, neither the strain will be coming. This question is regularly asked in last 2-3 years in various PSU interviews. Okay. Now let us go to the question number 5. Now let us go to the question number 5. What it is saying, let there be rods which is placed between two metal plates. Okay, there is a rod which is between two metal plates. Okay, the metal plates are fixed and cannot be moved. Okay, the rod is fixed to one plate and the distance between the rod and the other plate is 0.1 meter. Oh my god! Like this, like this, like this, and that distance, that gap is 0.1 meter. This is, array likh le, 0.1 meter. Okay, the gap here is 0.1 meter. This gap is 0.1 meter. The temperature of the rod is increased by 12 degrees Celsius. Delta T is increased by 12 degrees Celsius. Okay, okay, okay. And the length of the rod is 300 mm. ये जो हरी भरी रॉड थी ना, इसकी लेंथ थी 300 mm. Okay. Now Young's modulus is given and the coefficient of thermal expansion is given. Find the axial stress. Find the axial stress. Okay. Find the axial stress. Find the axial stress. बताओ भैया, बताओ भैया, बताओ. Now see. What is L alpha delta T? Free expansion. If it is free, there is no fixed, there is no supports, nothing, it is free. What is free expansion? Free expansion is L alpha delta T. Can anybody tell me the value? Free expansion is L alpha delta T. कर दो यार. कहाँ है? Length कहाँ है? Length का 300 mm. So 300 into alpha. कहाँ है alpha? 10 की power minus 5 into delta T. 12, this much mm. So 300 into 10 की power minus 5 into 12, this much mm. So 12 into 3 is 36. 36 into 10 की power minus 3 mm. 36 into 10 की power minus 3 mm. Please check. Please check, यही आ रहा है. Please check. Okay. 36 into 10 की power minus 3 mm. Are you getting the same value? एक बार बताना भाई. एक बार बता दो भाई. एक बार मैंने कहीं तो निकाला था. मैंने कहीं तो निकाला था. वो कहाँ निकाला है? वो मैं एक बार चेक कर लेता हूँ. It is 30. अच्छा 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 अच्छा. Alpha delta T is 120. Sorry. This is delta T is 120. 120 है. तो 36 इंटू कितना आ रहा है? चल कुछ तो क्वेश्चन में गड़बड़ी है. 0.1 mm है भाई वो. भाई वो 0.1 mm है. ये गैप जो है ये 0.1 mm का है. कहाँ गया? mm. ठीक है. तो वो वैल्यू कितनी आ रही है? 36 इंटू 10 की पावर माइनस 3 आ रही है क्या अभी भी? अब तो 36 इंटू माइनस 2 आ रही होगी. 0.3 माइनस 2 आएगी ना, 120 होगी ना उसकी जगह. तो तो 0.36 mm is the free expansion. 0.36 mm is the free expansion. अब देख लो, और हमारा 0.1 mm, तभी मैं सोच रहा कुछ गड़बड़ हो रही है. तो भाई ये यहां तक होता 0.36 mm. This wants to increase 0.36 mm, but it can only be increasing 0.1 mm because only gap is 0.1 mm. So this P is coming. This P is coming. So this P is pushing it. How much? Not from here to here. It is pushing from here to here because now support is only up to here. So what is this length? This is 0.36 free expansion. This is 0.1. So this is 0.36 minus 0.1 mm. Because this is pushing only from here to here. Support is here, guys, not here. So this is pushing it only up to this point. P by A is the stress, L and E is given. P by A is the stress, L and E is given. From here, the value you are getting as 260 megapascal. Give me yes or no. Give me yes or no, everybody. जल्दी से बता दो. Yes, yes, Arun. Yes, Pawan. Good, 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 good. Everybody got the question. Everybody got the question. Excellent. 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 Any doubt to anyone? Let us move further then. आगे चलें भाई. आगे चलें. Okay. Modulus of अरे ये तो बच्चा वाला क्वेश्चन है. Okay. E is equal to, I told you relations ना. I told you some relations. This one. Okay, E is this relation. E is equal to 2G1 plus mu. Modulus of elasticity is 200 and modulus of rigidity is 80. 2 into 80, 1 plus mu. So from here mu is equal to 0.25. So mu is equal to 0.25 is only one option. Even I don't know the other formula, I can get it. But still, K is required. So K, the E is 3K 1 minus 2 mu. E is equal to 3K 1 minus 2 mu. So E is how much? कहाँ गया? 200. 3K 1 minus 2 into 0.25. So 200. This is 1 minus 0.5. 0.5. 1 minus 0.5 is 0.5. So from here, what is the K minus? This is K minus mu. K 3K 1 is 3K 1 minus 2 mu. E is equal to 3K 1 minus 2 mu. From where what is the K coming? Please check here. 400 by 3 na. K is equal to 400 by 3. And once the 400 by 3 is coming, this will be D option. This will be D option. Yes, Arnab bhai. Arnab bhai, you are absolutely correct. Okay, now this is a challenging question yaar. If you can do this, then elastic constants, I can't think that any question, if it comes in exam, you will not be able to solve. If you can do this. See, suppose let me take this. B option first. B option first. Guys, we have our relation E is equal to 2G1 plus mu. If E is equal to G, if both of them are same, so it will be cancelled. It will be cancelled. So 0.5 is equal to 1 plus mu. So mu is equal to minus 0.5. If mu is coming minus cannot be possible in metals. Metals not possible because metals mu is always positive. Mu minus only for human tissues and polymer, not for this. So G is not equal to E, and if G is not equal to E, then that means C option is not possible. Because in C also there is G is equal to E. Now let me take G is equal to 2K. This one. Let me take G is equal to, you know this relation, mu is equal to 3K minus 2G upon 6K plus 2G. If G is equal to 2K, if G is equal to 2K, putting here 2K, 3K minus 4K, 3K minus 4K camera upon 6K plus 2G, G is equal to 2K, so it is 4K. So mu is equal to minus K upon 10K. So mu is equal to minus 0.1. Again not possible. Not possible. दिख रहा है नीचे का? Not possible. So this is also not possible. Now let me take this. K is equal to E. So if K is equal to E, कहाँ गया? Take this relation. E is equal to, if K is equal to E, we know relation E is equal to 3K 1 minus 2 mu. If K and E are equal, it will be cancelled. So 1 by 3 is equal to 1 minus 2 mu. So 2 mu is equal to 1 minus 1 by 3. That is 2 by 3. 2 to 2 cancelled. Mu is equal to 1 by 3. 1 by 3 means 0.33. It is possible. It is possible. So D option. Give me yes or no. Give me yes or no. Give me yes or no. Okay. So now this is your homework, and I answer on comment box. Answer on comment box. Your answer is required there, guys. Okay. So guys, so PDF I'll be providing in my Telegram group, that is Civil by Abhinav sir. 50 mark series is there for civil and mechanical both. This is the schedule. Now I am coming 9 p.m. Okay. So 9 p.m. I am coming now with strain energy, beautiful shortcut. Then Dheeraj sir will be coming for other subjects, SOM other topics, and then fluid mechanics will be there, guys. So let me tell you that again, are you coming at 9 p.m.? This is the 50 marks combination of civil, as 50 marks is covered here. Okay, soil is not of 16 marks, but I will be covering those topics, and average of those topics last 5 years is 4 marks. That is how it is counted, 50 marks. For mechanical also it is 50 marks. So this is 9 p.m. tomorrow. Are you coming, guys? Are you coming? Let me share you the link also. You can just like it right away now. Are you coming or not? आ रहे हो भाई कल? Are you coming tomorrow? Just like it, guys. Put a comment there on the chat box if you are coming. If you are coming. Okay, that is the link. And let me tell you where the PDF you will be getting. PDF you will be getting just after 3 to 4 minutes. I'll switch off the smart board. And after I switch the smart board, I'll be putting the PDF of this session in Telegram group. It is there. Now the guys, I have 10 p.m. my app series going on. Not today. Today is no class on the app. But now it is on 6th and 7th July. Okay. 10 p.m. I will be available on app also. This is my app schedule, that also I'll provide in the PDF. For now, my app class is on 6th of July. Okay. Thank you, guys. This is the workshop that is taken by Rathi sir. It will be on 4th July at 7:30 p.m. Please do register for this workshop. And scholarship test is on 9th of July, from where you can get 90% discount on our courses. It is free of cost. Just attempt this and get the 90% discount. Okay. I hope you enjoyed the session, guys. Now I will be seeing you tomorrow at 9 p.m. for this session. Okay. I have provided the link of my Telegram group and the link of the tomorrow's session. Thank you, guys. Take care. Take care all. Thank you. Thank you.